Okay, so in this video, we're going to continue our work with polynomials, and now we're going to add and subtract polynomials. And so in the previous video, we talked about what polynomials meant, and we talked about what the word terms meant, and we talked about degrees. So I will refer you to that video if you want a little bit more of that terminology. So notice here in our first example that we're asked to add together two polynomials, each with 4 terms. And how we know that they are two distinct polynomials is that they're separated by these parentheses, and we're adding them. You see the symbol in between the two polynomials. For a bit of review, the polynomial on the left, 5x cubed minus 8x squared plus 6x plus 2, has degree what? Do you remember? So the degree is 3 because we always look for the variable with the highest exponent, and that exponent determines the degree when we're talking about a single variable like these problems are. And notice that the second polynomial also has degree 3. Okay, so here's the interesting part. When we add polynomials or subtract them, we want to work with terms that are alike. And what that means is we're going to work with the terms that have variables with matching exponents. So you're going to notice that in these two polynomials, we have 4 sets of 2 like terms each. We've got this 5x cubed and the 6x cubed. Those two would be considered like terms because they both have an x cubed as part of the polynomial, an x cubed in their term. Okay, and how we add then is we're going to add the coefficients. So we're going to add 5 plus 6 and get 11x cubed. All right, so that's the first set of like terms that we're adding. The next set of like terms will be this negative 8x squared, which will get added to the positive 9x squared. And again, we're going to just work with those coefficients, the negative 8 with the positive 9, and that's going to give us a 1, isn't it? So our next term in our answer will be plus x squared. We don't write in the 1 normally when that is our coefficient. For the next pair of like terms, we have a positive 6x that we will add to a positive 2x, and again we're going to use the coefficients, so we will add the positive 6 to the positive 2, and that will give us a plus 8x as our next term in our answer. And then for our last step, we're going to add together the two constants, the 2 with the negative 8, the positive 2 with the negative 8, and that's going to give us a negative 6. So notice that we started out with 2 polynomials that had degree 3, and it ends up that we ended up with a polynomial with degree 3 again, so that was kind of cool. 4 terms, and again we only added together the like terms. Those were the terms that match with matching variables and exponents, and we added their coefficients. We did not mess with their variables and exponents. Did you notice that? We worked exclusively with the coefficients. Let's go to the next example here, and now we have 2 polynomials. They have 3 terms apiece. Do you see that? Do you remember what that's called? Polynomials with 3 terms? Those are the trinomials. That's from our last video. Okay, so we have 2 trinomials. What degrees are they? If you said degree 4s, you're right. They're both of degree 4. Good. And we're adding them again. We're adding them. So really the parentheses here in the additions, they're just being used to separate the 2 trinomials from each other. But now when we're going to go and add, we can ignore those parentheses and work with the coefficients of the like terms. So we've got these 2 like terms here, the 2 negative 10x to the 4ths, which are going to give us negative 20x to the 4th. Again, we're working only with our coefficients, keeping the variable and exponent intact. And then our next pair of like terms will be the 4x cubed with the 5x cubed, and we're going to add those 2 coefficients together, and we're going to get plus 9x cubed. And then we have this x here, and he's kind of by himself, isn't he? We don't have a matching term, like term, in the second trinomial, so we're just going to rewrite him right here as our next term. And then do you notice the constant? That's the last term that's left here. Now we've got this extra constant here, plus 4, and that's also going to be rewritten as part of our final answer. So even though we started out with 2 trinomials, our answer ends up having 4 terms. doesn't it? Do you notice that? Okay, so we ended up with this polynomial, and again by adding the like terms. When we go to subtract polynomials, we have an extra step. And it's just like when we subtract integers. We're going to change the signs on that second polynomial. See that little subtraction here? We're going to change all these signs in the second polynomial. And that's going to allow us then to change this middle subtraction sign to an addition. So we're subtracting a negative 2x to the fifth here. That's equivalent to adding a positive 2x to the fifth, right? Adding the opposite. And if we're subtracting a positive 7x to the fourth, that's equivalent to adding a negative x to the fourth. And if we're subtracting a positive 9x squared, that's equivalent to adding a negative 9x squared. And if we're subtracting a negative 7x, that's equivalent to adding a positive 7x. So notice how every single sign, and you want to make sure you don't miss one, every single one of our original signs is now changed to the opposite. So I just rewrote that. So let's combine some like terms now. The first set of like terms will be the negative 8x to the fifth with the positive 2x to the fifth. And that's going to give us a negative 6x to the fifth. The next set of like terms is the negative 3x to the fourth, which is combined to the negative 7x to the fourth. And that's going to give us a negative 10x to the fourth. The next set of like terms is the negative 4x cubed combined. Oh, there's no x cubed term in the polynomial on the right. So we're just going to write a negative 4x cubed. Now I'm noticing that on the right hand side I have a negative 9x squared. So I'm going to go ahead and write that in next as part of my answer. I like to have the answer have descending powers of x. You notice we're making sure that our answer is in descending powers. Just makes it easier when we go later on to do more work with our polynomials. So it's a good habit to get into. Then I have the plus 7x. And then finally I have our negative 5 constant here. There's our answer. That's a big polynomial. It has 6 terms. Over here we're once again subtracting. So we're going to go ahead again. We've got to change all these signs. Change all 3 signs. So we get this changes to a plus, but it's a negative 12x to the fourth. Negative x to the 12x to the fourth. And then here we get a positive 11x, and then we get a positive 2. We're using distributive property with that subtraction symbol, again changing to the opposite symbol. Some students like to think of this as there being a little invisible negative 1 here in front of the parentheses that's getting distributed in the second parentheses. So whichever method makes more sense for you, then go ahead and use that, right? As long as you make sure that all 3 of the terms in the second polynomial get changed. And then I'm rewriting. Okay, I'm going to get rid of this plus here and just leave that minus. Okay. And now let's put in descending order. So we've got the negative 12x to the fourth with no like term. Then we've got the negative 7x cubed with no like term. And now we're going to go ahead and combine the negative 3x with the positive 11x. So that's plus 8x. And we're going to combine the positive 1 with the positive 2. So that's a plus 3, and that should be our answer.